Also, for those of you who are returning attendees and members, please use this as an opportunity to support all of our colleagues and consider checking out a new session with somebody that you might not recognize. We also want to acknowledge several cost-saving measures that you might notice throughout the conference. As you probably saw when you registered, there are no giveaways this year, and we're also having a bit less food. We just want to acknowledge that in advance. But we would like to thank the SPR Board of Directors for doubling down and capitalizing on the opportunity to really support our mission and our values by continuing to fund all of the travel scholarships and activities that we've always had for all of our early career scholars and our scholars who've been systematically oppressed or marginalized historically. So thank you to the board for keeping those programs despite our current funding situation. I'd also like to acknowledge a few changes in the plenary sessions that you might notice. We will still have 4 sessions as usual, but the number of speakers will vary. So you'll see a little bit of a change. We're very happy to welcome 2 to 3 speakers in each plenary session, but they will be changed up a little bit. I'd also like to acknowledge all of the winners of our abstracts of distinction that were released this morning, both in the sessions and in the posters. So congratulations to everybody there. And if you have an opportunity, please stop by and check out all of our posters, particularly those that are very relevant to our conference themes. I'd also like to tell you in advance about the plenary session on Friday. That's plenary 4, which will be held in this room. And the focus of that plenary is ethics and equity. When we were planning this conference topic, which hopefully you know is data science and technology, the single biggest reaction we got was that everyone wants to talk about ethics in this space. And we feel that that's very important to have an open and robust discussion about that. So our first 3 plenaries will be as usual with our lovely speakers. And at the end of each plenary session, there will be a very large QR code that is posted on the slides as we exit. Please feel free to scan that code. And if you have any ethics related questions, please submit them. And I and our president, Brittany Rhodes, will be curating those questions. And the session on Friday, we've invited all of our plenary speakers back to tell us ethical lessons that they've learned that they feel are critical, but also to have a panel response to the questions that you submit and that the board submitted. So please join us for that. Otherwise, if you see me around, I will be in this flowered jacket or this lovely headband supporting my colleagues. Just let me know if you have ethics questions or anything at all you'd like to say about the conference. We're happy to incorporate those as our funding continues. Otherwise, I'd just like to wish everybody an inspiring and invigorating conference. I'm very happy that we're able to have this despite challenges that our field is facing. And I'd like to pass it over to Sarah Lynne and also acknowledge Holly Hagle as the chairs of our first plenary. Welcome to Seattle.
Good morning, everyone. The application of artificial intelligence raises exciting possibilities for advancing equity and action in prevention science. This can encompass examples of bias detection and mitigation, AI-based content generation, and data visualization for translation of knowledge from algorithmic-based studies. This session is tailored for prevention scientists with content that will be accessible to individuals just learning about AI and prevention science, as well as those who may have some extensive experience. It aims to expand AI literacy among prevention scientists and inspire future research. The speakers in this plenary will discuss data visualization, bias, and engagement to promote equity and action in prevention science. We have, for this plenary format-wise, we'll have our invited presentations, and afterwards it'll be immediately followed by a roundtable with all of our presenters, in which there'll be opportunities to engage directly with the speakers and with each other. So please stay for the roundtable session that follows. It'll be a great opportunity to ask questions that are inspired by the presentations and the network. The session itself will just be the presentations, though. As Dr. Bethany Bray mentioned, the final invited plenary session of the conference is taking place on Friday at 10:45. Is going to focus on ethics and equity. This is the QR code that she mentioned, where we're inviting all of you to share with us in advance any ethical scenarios that you've faced, either recently or historically. We're happy to keep names and institutions confidential, but again, as she mentioned, the goal is to inform our discussion of ethics in this final plenary. Thanks in advance for your engagement. And now I'm excited to introduce our first speaker. And I'm going to be moving and she'll be coming and bringing her laptop up while I do this introduction. So there'll be a little bit of shuffling happening here. Okay, let's see. All right, our first speaker is Dr. Karla Saldana Ochoa. She's an assistant professor in the School of Architecture at the University of Florida. She directs the AI and Architecture Graduate Certificate Program and oversees the SHARE Lab, a research group focused on developing projects that leverage the interaction between artificial intelligence and human intelligence. At UF, Karla works with digital twins, which she defines as intelligent environments, focusing on how this technology is applied across various scales, from buildings to citywide infrastructure. Today, Dr. Saldana Ochoa will discuss AI applications through digital twin implementation to understand risk and inform decisions and future research on ultimately improving health and preventing negative health outcomes. Specifically, her work is in using AI to create digital twins of the built environment in which we live, and they can be used alongside predictive modeling to understand how different future scenarios might change the world in which we live, work, and learn, and predict impacts on our health and well-being, both physically and mentally. Thank you, Dr. Saldana Ochoa.
A pleasure. Thank you, Sarah. It's my first time here at SPR, so I'm really glad that I get to talk to you and then eventually discuss later on the panel after this presentation. So yes, I am not in the health science. I'm an architect, a landscape architect, and a PhD in technology. But I think that I have to, I can share some of the ways that I have implemented different AI algorithms to create digital twins and why that is relevant in the health outcomes. Because we are going to be seeing how important is the space. How does it matter if it is related to a geolocation, that is related to a community? That's something that we're gonna see at the application in this work. So my background is on disaster response, and I wanted to bring that here because we can also talk about disaster prevention. And I'm going to show you two examples of how we have built digital twins using different AI models for disaster or hazard prevention. Around the world of disasters, there are several other words that appear for assessment. So there is, for example, hazard, which is the likelihood of a disaster occurring. There is vulnerability, exposure, and risk. What I would like us to think about is that what I'm going to present to you is ways that we can assess risk. And risk in this way is referring to the overall impact and consequences that a hazard has on the community. And so we're going to think about risk to be able to develop prevention strategies. And one of the things that I want to talk about is that even though we have technological advancements, and there is a critical disconnection between the quantitative ways that we measure risk and the qualitative perception of risk that community has. And here's what happens. So when a disaster happens, though there are many maps, there are news, there are reports, people stay in their houses and they say everything was gone. We weren't really expecting this, and because we were never flooded. So even though we share the information, we have all the studies, we have the technology to do the modeling, people still don't do it. And here's the questions that I want to bring to you today. So if you think about quantitatively how to assess risk, you will say a question like this. So what is the risk to a community or a city if it is impacted by storms? So how can you find the different indexes or information that can help you find that quantitative index of risk? But then the other question that we have here is what a community perceives to be at risk when a storm happens. So these two questions happen to be talking about the same subject, but they are not cannot easily be addressed by the same methodology. So I want to invite you to think about how can we bring this to quantitative and qualitative ways of assessing risk through technology. So right now what we have is that we have state-of-the-art computer graphics to be able to develop different 3D environment situations. So there are ways of modeling. So we call them 3D models because you can do them through semantic modeling. And if you've ever modeled or 3D modeled something before, you'll do it through a software that you can start like drawing in a 3-dimensional space and then assigning names to those elements that you're creating. And that's called semantic modeling. There is another at the end of the spectrum, something that is called photogrammetry modeling, which is based on images. So you have, for example, if I want to model this computer, I'll take images 360 degrees around, and then I'll use photogrammetry to triangulate them and create a mesh. And then there is something in the middle that is more or less like a parametric modeling where you define rules, and based on specific drawings that you had before, you can create geometry. So we've been developing different algorithms and different methodologies to be able to create environments. And we're being very successful about that. And in order, I mean, in our success of creating environments, we have created this ability, or we are able to create cities in this way. So what you're seeing here on screen is a point cloud model of Jacksonville that we were able to create that, transform that into a digital twin of Jacksonville. And for us, what is important about creating these 3D environments is that we comply with these 4 I's. So the environment has to be intense. So it needs to embed information and it needs to be visually rich. It needs to be immersive. So it should enhance the user experience and perception of the environment. It has to be interactive. So it should be dynamic to whatever user input you have. And then it should be interconnected. So it needs to be connecting to the physical asset that you model. So we did this. So let's say we solve it. We can create 3D environments. Let's go back to the data right now. I think I put here 4 buckets. These are what I call information models. So information models is everything that it has to do, for example, with environment. We have data sets that are collecting information, for example, about topography, flooding, precipitation, zoning, all of this is about the environment. We also have information models about infrastructure, roads, electricity cables, and so on. We also have information about buildings itself, facades, materials, doors, windows. We also have information about population, the demographic information about density, number of kids, and so on. So we've created this bucket of information. Let's say we solve that. We have those buckets. We have also plenty of data about health outcomes. We have plenty of data about patients, health reports. And I saw yesterday on the panels that we've leveraging them. So let's say we have that. And we also have AI models. What you're seeing on the screen is this bubble, inner bubble going outdoor, growing, let's say. There are many keywords around AI. And what I'm coming to tell you is that not everything that is deep learning, not everything that is AI can be deep learning. So for example, there are algorithms that are AI, but are not machine learning. There are algorithms that are deep learning, but are not machine learning. So one of the things that I want to emphasize is that in 1996, one of the main books about AI was saying that AI has specific areas of research. So there was computer vision, natural language processing, robotics, and so on, because they were based on specific data types. Right now, we're experiencing a movement where there is this multimodal data fusion approach, which means that you can work with images and text together to create a model or train a model to predict whatever you want to predict. So now the silos of data specific type has been blurred completely. So before, machine learning was part of an AI background. Now machine learning has taken everything on AI. And we can also say right now, we have solved many problems using these algorithms. So how can we leverage these 3 things that I just claimed that we have more or less solved, right? So we solved the 3D environment creation, the 3D models, we have solved the information models, and we have solved, or we have created AI models. So I propose to think about having them all join into something that I call digital twins. So digital twins are these virtual environments that leverage artificial intelligence, information models, and the 3D environment creation to create these virtual replicas of physical systems or systems that exist, right? They don't need to be concrete, that enable improved decision-making, predictive modeling, and efficiency across various domains. And within what you see underneath, and this is my brain, so there is no theory yet about this, but I believe that digital twin also lives in a continuum. So a continuum, that means that you can have a digital twin that is about description. So it's about how the asset looks like. Then you move to a digital twin that can be about the status of the information when you have the environment and is fed with the sensor data from the physical asset. So you have a 3D environment, the replica of the physical asset, now with data and historical data, right? Because data is real time. So you collected it right now, but then you collect in the next second. So this data that you collected today, right now, it's historical. And then you can do, because you have historical data and real-time data, you can start doing predictive analysis. So you can have digital twins that are existence, status, operational. And then what is really interesting is that then you can bring something that I will think is the core of digital twins, which are the simulations or the physical simulations that you can build in. So there are many mathematical models that live isolated from all of this data reach, all of this 3D environment creation, all of these information models that could come and live into digital twins. And then the next one, I call it cognitive, but I would like to, that's say cognitive, but I will refer to it as intelligent. Imagine if you're able to interface with this virtual reality or virtual replica or this digital twin through agents that can help you guide and find solutions to questions that you have. That's what I see it's moving forward. Right? Benefits to digital twins could be to better understanding facility utilizations if you have the asset as a building, to have this proactive, informed decision making or consensus making. I also believe that it can save or cost savings, and I will show you a project where we have shown that we can reduce energy consumption by using digital twins. And then in the case of the University of Florida, we are leveraging the talent and computing resources that the university has invested. Because what I said, we have solved, we were only able to solve because we had the computational power and the storage resources to run the models, store the data, and then visualize the data. So this is what I will say that you have helped us create digital twins. And then it can also help us for emergency response or prevention. This is what I want to talk to you right now. So digital twins, you can create digital twins of the Earth, right? The scale is large, and you can model weather-related, you can embed weather-related models. You can also do digital twins about the territory, so the whole city, right? It really depends on the scale, and the scale relates to how much data, what is the minimal unit of data aggregation, what is the minimal unit of time that you're gonna see the data being projected, the models to be predicting. You can also do through landscape. So all of these are some of the projects that I worked before in collaboration with several partners. This is a design project for creating coastal resilient solutions in the Gulf of Mexico through digital twins. And then you can also do at the scale of the building. Let's go back to our question. Right, we said we have a lot of methodologies for quantifying risk. Right, we could look at our data. We could start running some statistical methods to identify what are the indexes that show that this is more vulnerable or less, let's say less or more vulnerable to a particular condition. Then still, how can we show this in a meaningful, communicative, consensus-making way? And I say that digital twins can help us do that, because a lot of the times when we communicate information, our brain builds different models of what we're looking at. So sometimes we read an abstract, but the way that I read, understand, and then talk about it could be completely different than another person, or look at a map or look at the picture. So there is always saying the picture words 1,000 words. I think a digital twin can be worth 1,000,000 pictures. So the first project that I want to show today is called JaxTwin, and this is an innovative collaborative project to create an urban digital twin. And this is a project that models 32,000 buildings across Jacksonville and utilizes 3D environments as its foundation. The question that we have here is there a correlation between weather hazards, infrastructure like septic tanks, and health outcomes? Can we see these three in one side? JaxTwin has key capabilities as it's able to correlate several systems, including flooding, visualization. It is also help us and is interactive with the built environment, and it helps us for scenario planning, and it has this dynamic user feedback. This feedback allows us to have this real-time testing for optimal building locations to avoid flooding, and then also to understand what are the conditions that happen after a natural disaster. Another project that I want to show today, and this is probably, if you're in the built environment, this will make a lot of sense. So this is a UF building digital twin, which focuses on creating a virtual replica of university campuses to enhance decision-making and create efficiency in spending. So what you're seeing on the screen is a building called the Ramos Laboratory. And this building or this digital twin consolidates various type of data and platforms in one location. So you can have architectural models, you can have engineering models all in one location. It also integrates real-time data. So we embed a sensor that is capturing temperature data real time and is feeding that information to the virtual digital twin. And it's also helping us to monitor the condition of space. And what you're seeing here, we're also exploring ways of visualizing the data, because you can just put numbers and say that the room, like your thermostat, your room is 77, your room is 70, but we were saying, can we transform those numbers to colors, right? And so we're seeing this color changing and the temperature reading. Additionally, we developed a connection with Energy Plus, which is a software or let's say a methodology for running energy reports. So if we have real-time data, we have weather conditions, we can run a predictive model to tell us, during this time of the day, we saw that you use this much energy, but we recommend you use less. So the moment we run this report, we're able to suggest recommendations to improve spending on energy. And then the last case study, for example, this is, we are using mobile scanning to monitor the construction phase. And here, for example, we use this to identify construction volumes, track tasks according to the schedule, and I see what's the progress during the construction phase. And what is interesting is that this digital twin can also act as an archive of not only numerical data, but also three-dimensional data. So you can always go back and see what happened during that day and how did it look. When you have to, for example, make a renovation, or when you need to demolish something on the building. And here's the last case study. So we're doing scenario testing, such as an evacuation for safety management. And here we're doing through fire emergencies, or this could also be used for any other type of hazards that happen during buildings. And the idea here is to aid in creating safe space, regardless of this hazardous scenario. And what I say is, by leveraging these technologies, this digital twin provides a valuable insight into building performance and creating safety, and it contributes to this idea of consensus making and informed decision-making processes. Okay, so we publish a lot about this. These are our partners. We partner with industry and with institutions at UF, and then we also have a build partnership with universities in Hong Kong and in Europe. And I just wanted to show you a little bit about this. That QR code leads you to all the publications that we do at the lab. The Share Lab is titled Spatial Human-Centered AI Research and Experimentation, SHARE for short, and we try to do a human-centered approach every time. And we have a methodology that helps us identify how to embed AI in our projects, and this is by identifying whether AI should be used as a tool or as an instrument, because AI is so versatile that can be used as an instrument like a violin, that it really creates, articulates a masterful piece if there is a masterful human playing it. But it can also be used as a tool, like a hammer. Anybody can, and everybody can use a hammer because it's built for that task. There is no specific training for that, but it's very efficient and it can do the job. So I think AI can be both. How do you define what is for what? My lab, it's full of students, young people, myself, really excited, always talking about these technologies. And as I said, we always ask, does this question need AI? If the answer is no, then why are we talking about it? Maybe just do it as we were doing it before. And if the question is yes, whether it should be used as a tool or as an instrument. Future steps in my life. I started my professorship 2021. And the lab works with trying to do big data analysis for designers, and how can we use AI to empower or augment architects' capabilities. We work in generative AI using not images nor text, but to generate 3D models that are structurally informed. We work with digital twin applications. This is a part of the work that I show you today, but then also we are partnering with Emory University in Atlanta to be able to join these spatial features with medical health records to aid in public health responses. So I just wanted to share this with you because if you have any interest in any of these 4 lines, I'd be very happy to talk about collaborations. I do enjoy collaborating, and I think I have my 20 minutes. Thank you.
Thank you so much, Dr. Saldana Ochoa. Next, I have the pleasure of introducing Dr. Eric Rice, a professor and the Associate Dean for Research, as well as the founding co-director of the USC Center for AI and Society. Dr. Rice specializes in social network science and theory, as well as community-based research. His primary focus is on youth experiencing homelessness and how issues of social network influence may affect risk-taking behaviors and resilience. For several years, he's worked with colleagues in computer science to merge social work science and AI, seeking novel solutions to major social problems such as homelessness and HIV. Today, Dr. Rice will discuss the role of researchers engaging community stakeholders in AI research. Please join me in welcoming Dr. Eric Rice.
Good morning, everybody. It's great to be here. For those of you who might be a little bit intimidated by AI as a topic, I wrote my notes by hand. So I'm a Gen Xer. I grew up with telephones that were not computers, and I learned how to write with my hands. And so I'm going to share a lot about how, maybe for some of you, a way of thinking about how to enter into this space, because really I entered into this space through collaborations, not as somebody who was a data scientist by training by any stretch of the imagination. And the topic of this presentation is really that AI-powered prevention science needs community-engaged research. I have been working with computer scientists since 2014, so a little more than a decade at this point. And back in 2016, I founded a center with some computer science colleagues, including Dr. Vayanos, who's been my friend and colleague for a very long time, at USC, that was a joint center between the School of Social Work and the School of Engineering, with the called the USC Center for AI and Society. And the explicit goal of this center was to come up with novel approaches that were interdisciplinary approaches, out-of-the-box approaches to tackle some of the thorniest problems that exist in the world, particularly in the context of prevention. And the focus of the work really has been on 3 buckets. One is around homelessness, another is around health and well-being, and the third, which relates to our previous speaker, is around the human response to climate change. We have, from the get-go, in part because of my partnership in this, been deeply concerned with how do you bring community partners into this process in a meaningful way. So really, we never envisioned this as AI-driven research, or even as prevention science-driven research. It was really, how do we bring together social scientists, how do we bring together computer scientists, and also how do we bring together communities so that all three of these stakeholder intellectual, thought leaders can actually contribute to the solution of these problems. Okay, enough preamble. Probably the easiest way to get into something this esoteric is to actually just give you an example of what have we done, right? So the context of the particular project that I'm going to share with you today is, how do you design fair, equitable prediction tools for vulnerability when you're thinking about homelessness? So homelessness in Los Angeles and most major cities in the United States has really reached a crisis level in recent years. In LA, we've got 75,000 people that are on the streets or in emergency shelters every day. And we only are able to house about 25,000 of those people every year. So there's a huge disconnect between the demand for resources and the supply of resources. And why is this relevant to you in prevention science? Well, housing is the #1 intervention to prevent the long-term health and mental health adverse consequences of homelessness. And from a planning perspective, every community is stuck with this really thorny problem of, who do we give these resources to and who do we leave literally out on the streets, okay? Now, housing and urban development for about a decade or so has been really pushing the idea that the most vulnerable, and I put this in air quotes because how vulnerability is defined is very mushy. Mushy is maybe not the right word, ill-defined. And so we, in this context, we're really concerned with, how do we prioritize the people that need these resources the most, so that we put the people that are in greatest need, that are at the most risk of having these adverse consequences happen to them? How do we prevent bad things from happening to the people that bad things are most likely to happen to? Put them at the front of the line. But then the challenge is, can we do this in a way that's fair? So to make matters more complicated in Los Angeles, and this is the case in most urban settings, but in Los Angeles, I know the numbers, 9% of our population are Black. 30% of the people experiencing homelessness in Los Angeles County are Black. So layered onto this whole complex issue of who gets resources and who doesn't get resources is the thorny issue of equity. So this project I'm going to dive into is about this, but because you all are a prevention science audience, I'm happy to let you know that after doing this kind of work for about a decade, I finally this last year decided maybe I should actually write about how to do this kind of work. So my colleague Lindsay Young and I have written a paper that's under review at Prevention Science right now that's called AI-powered research needs community-driven research. And in that, we propose a formal model for how one actually does this kind of work, which we think is important in order to help other folks do this kind of work. So if you think about sort of classic prevention science, we can think about it as having, at least from my perspective, roughly 7 stages, right? You go from problem conceptualization to data collection, to identifying risk and protective factors, to designing an intervention, to doing intervention piloting, to doing intervention efficacy testing. And if you're lucky, years and years later, you actually have something that's implemented in the world. And what we would suggest in this model is that AI can play a really important role in every stage of this, as well as community should be playing a role at every stage in this process. Now, the 2 things that I want to point out is not only that AI and community can have a place at every stage along this process, but the second thing is, we usually sort of imagine this, or at least we talk about this broadly, as being something that is a more or less linear process, right? Like you go from problem conceptualization all the way to implementation in this sort of march forward and through time. But the reality of doing this kind of work is that there's often moments where we think about sort of these feedback loops, where what happens at one stage informs what happens in a previous stage. So my colleague Lindsay actually is much more poetic, and she came up with the phrase moments of critical retreat. And I really like this idea, because what it suggests is that there are these moments when especially the community will give you feedback about what you've achieved at, say, stage 3. and say, hey, wait a minute. We need to think about how this is impacting what we were doing maybe in stage 2 or in stage 1. And it's a very humbling part of the process when you're working with community on these projects to be told that you need to go back a few steps, but it's a critical part to actually implementing technology solutions, which the community needs to have a lot of trust in this process in order for it to work. Okay, so back to the example. The community in this case actually defined the problem that we were working on. We didn't define the problem. The community in 2018 released a report by a group called the Ad Hoc Committee on Black People Experiencing Homelessness, in which they raised a whole host of issues around race equity that they saw happening in Los Angeles. And they actually identified within that report 65 recommendations for Los Angeles to engage in to address race equity in homeless services. 4 of those were actually targeting this prioritization process. So what I want to share with you is just 2 quick slides. This one basically shows that the actual allocation of housing resources by race was relatively equitable at the time that they put out this report. What wasn't equitable, however, was the outcomes that were coming out of this process. So if you were Black, you were about twice as likely to return to homelessness as if you were white or if you were Latinx. So 14% versus 8 or 7%. And the community was deeply concerned that part of what was driving this inequity was the actual prioritization process. So there was a tool that was used in Los Angeles and in hundreds of communities across the country called the VI-SPDAT. I can't even remember what the VI-SPDAT stands for. I've been working on this stuff for 10 years. It's like Vulnerability Index, Service Prioritization, and something. It's a 35-question tool that people answer yes or no questions about terrible things that have happened to them. From those 35 questions, a score that ranges from 0 to 17 is established. And then based on your score, the higher your score is, the more that you are put to the head of the line. And the question that the community really posed to us, or posed to the world in this report, was, is this process actually fair? Was this designed for white people, and Black people are being left out in the cold, as seems to be the case here with the returns to homelessness? So in 2019, in Los Angeles, the Conrad and Hilton Foundation and the United Way came together and put forth a call for proposals to researchers to actually explore this existing tool, whether or not it was fair, and if it wasn't fair, could a new tool be designed that could prioritize people? Because we still have this problem of needing to actually prioritize who gets these precious few housing resources. But can we do it in a way that's actually fair and doesn't exacerbate race equity? And so my team, including Dr. Vayanos here, who will share even more of the details of this, was lucky enough to be the recipients of this award. And for 3 years, we worked with the Los Angeles Housing Service Authority and a whole bunch of other community partners on looking into these tools and how to redesign them. Because we were really focused on trying to maintain this community engaged process, we were very deliberate in how we built out community partnerships in this project. So we had 2 distinct community groups that we built out. One was a community advisory board, which actually in the end became a community working group. And this was a group of 20 individuals who were themselves people with lived experience of homelessness, and/or they were folks who were caseworkers who worked in the trenches, actually delivering these tools and assigning people to housing resources. We ended up working with these people and met with them about 24 times over the course of the 3 years. And as I'll get into in a little bit, they became a critical working group in this, not just folks that we asked some advice periodically from. We also worked with what we called the Core Planning Group, which was a group of policymakers. So this included people from the Los Angeles Housing Service Authority, people from the Department of Mental Health in Los Angeles, people from the Ad Hoc Committee on Black People Experiencing Homelessness, as well as folks from the Hilton Foundation and the United Way that had given us these resources. And we met with them about 4 to 5 times a year over the course of this 3-year project. So the thing to understand about the stages of this project is that, so the stage one, okay, they defined the problem and we decided to engage them with this. Stage two is who's collecting the data. Well, in this case, it's actually the community collected the data. We're taking advantage of existing administrative data, hundreds of thousands of records of people who have gone through homelessness services in Los Angeles over the course of probably about the 5 years up to this grant, this project, which was running from 2020 to 2024, more or less. So the very first thing that we needed to do as we moved into stage three, which is to get into this risk and protective factors modeling, was we needed to actually define, what does vulnerability mean, right? So if we're going to prevent bad things from happening, what is it actually that we're preventing? And what's really important when you're doing data science, AI-driven work, is you actually have to work with data, right? So when we were putting to the community the question of what is it that we are trying to prevent? How are we trying to create an outcome that we can model with machine learning? We had to actually work with data that existed in our administrative records. And from that, the community came up with the decision that they wanted to work on what we called adverse outcomes, which was 4 concrete things that we could observe in the data what was linked to county data, which was hospitalizations, psychiatric holds, incarcerations, or death. So these are 4 things that if you got a housing resource, you should be able to prevent these things from happening. If you don't get a housing resource, those things ought to happen to you. So then the community asked us the key question that started this whole thing, which was, does the current tool do this in a fair way? And the answer to that question was no. And so what you can see here is the generalized false negative rates of the existing tool. And what you can see here is that white clients versus Black and Latinx clients, their false negative rate is much lower. So what does a false negative rate mean? Okay, so think about COVID days, right? You wanted to go figure out if you had COVID, right? So you went and you took a COVID test. If you got back a test result that said you were negative, if that was an error, that's what is a false negative. So you actually had COVID, but you were told you didn't have COVID. And so the consequences of this was that you probably went to work and you could have potentially gotten somebody else infected. Now, the consequences of a false negative in this context are maybe even more dire. What it means is that you actually are vulnerable to having one of these 4 bad things happen to you: death, hospitalization, incarceration, and psychiatric hold. But the tool says you're not vulnerable to those things. So what this means is that a high false negative rate for Black and Latinx clients means that, in fact, vulnerable Black and Latinx clients were not being put to the top of the line to get housing resources, and white clients were much more likely to be placed there. So the next question that the community asked us was essentially, can we actually fix this problem? And the answer to that was yes, because it turns out that when you're doing AI and machine learning work, if you are not attentive to potential sources of bias, you will often create algorithms that exacerbate those sources of bias. But if you are attentive to those sources of bias, you can add constraints into your modeling that actually say, well, let's not just look for the most accurate way of scoring this system, but let's actually make sure that it has an equitable false negative rate in this case. So with this in mind, we were really excited. We're like, all right, we've done a great job. And part of this process meant that what we did was we took these 35 questions that were part of this VI SPDAT. We got rid of the ones that weren't telling us much about variance, and we reweighted the scoring of the other ones such that it would produce this nice result. And because the community told us that there was a secondary issue, that it was a bit of a burdensome process, we tried to make this the most parsimonious model that we possibly could. So we came back to them with 9 questions and said, we can do this instead of 35 questions, we can do this with 9 questions. And that led to the first moment of critical retreat. The community was like, whoa, hold on there. 9 questions feels really thin. We're gonna decide who gets housing resources based on just asking 9 questions. And where's the questions about substance abuse? Where are some of the questions about victimization? Like, there are some face validity issues here, let alone, so you can have predictive validity all day long here, but if the face validity doesn't work, no community member is going to trust this. This is not going to work for us. So we had to go back to the drawing board and adjust our algorithm so that it was imposing less of a constraint on parsimony. So now we came back to them with a second round of this and said, all right, how about if we do 19 questions? It's still got the equity constraint built into it. It still has the accuracy constraints imposed into it. How do you feel about this now? Now they said, great, this is great. So we're thinking to ourselves, all right, we're ready, we're set, we're ready to roll this out. And they say, well, hold on, there's more issues. Now we actually want to go back, not just to stay in this stage for a while, but we actually want to go back to the data collection stage. Because one of the problems here is not just that the scoring system is not so good, but we hate these questions. And so I was like, okay, what does that mean exactly? And so what they said was, look, there's two major problems that are going on here. One is that the questions themselves are worded terribly. And the second problem is that the way that people deliver the wording of these questions is really insensitive. And it's particularly insensitive both in the wording and the process to two issues. One would be basically race equity issues. The second is for it to be trauma-informed issues. So what we did was we turned to the community group that we were working with, the Community Advisory Board, and they became our community working group. We said, great, why don't you identify for us the questions that are particularly problematic and rewrite them? So we went through a whole process, and it took months for us to do this, of them writing the questions, voting on the ones that they liked the best, iterating with them, piloting, pre-piloting those questions, and them also teaching us what was an appropriate and good and thoughtful process to actually engage in this work. And so then with that, we are finally able to go out and pilot test this work. So I'm going to share in the last couple of minutes just briefly what happened when we pilot tested it, and I'll let Phoebe really explain the mechanics of actually how all of this work works. But what we did was, after we had this new rescored tool with the rewritten questions written by the community, the new process, we worked with 9 different community organizations to pilot test this. We worked with 18 different case managers across these organizations. We did a relatively small acceptability trial with about 50 people. And this slide really just represents that this was a purposive sample wherein we had a client that represented the population of people experiencing homelessness in Los Angeles. And what we found was that when we did exit interviews with the clients, even though the old tool was reviled, the new tool and the new process was actually quite acceptable to the folks who were the people with lived experience. And they said, that they felt like they were treated with dignity and respect, and they understood what the questions were being asked. They also said that they had been asked if they wanted to take breaks after traumatic questions. And all of this is great. And when we worked with the case managers and did some semi-structured interviews with them about what the process was like, they also reflected back to us that, in fact, this was a really much improved process, where they felt like, especially around asking people with trauma-informed issues about taking breaks after they asked them a really tough question, that they felt that it was a much better process. And they also felt that the questions that were really sensitive questions around substance abuse and victimization in particular, we made it very clear in the new wording of the questions and the new process that, in fact, these would not be penalizing folks for their honest answers, and that this really helped put clients at ease. So the last thing that I'll share, since I'm 37 seconds over at this point, is that the impact of this work has just been so gratifying to me. If you actually do this kind of data science work and you genuinely engage the community in it, you will actually have a chance of having this work make a difference. Los Angeles decided that after seeing these results, when the data science that showed that the original tool was not fair, that the new tool would be much more equitable, after seeing the good work that the community partners did in rewriting these questions and how well this process was received, they said, forget about it. We're not going to spend another couple of years doing an efficacy trial. We're just going to implement this thing. So starting last year, they started training at scale people to use this new tool, which they're calling the LA HAT, the Homelessness Assessment Tool. And they are training, there's been hundreds of people that have been trained in how to use this, and it's now being used to assess thousands of people in Los Angeles to prioritize them for housing. They've also engaged with a third-party evaluator who's going to be looking to see how this process unfolds, because God knows you don't want to leave it to me to be the one who's going to do the evaluation of my own tool. And so we're really excited to see what happens, and we hope that this, in fact, does get us where we want to go. And we're thrilled that Los Angeles trusts us and the process enough to actually engage in it. So thank you very much.
Oh, there we go. Thank you, Dr. Rice. Our final speaker today is Dr. Phebe Vayanos, an associate professor of industrial and systems engineering and computer science at the University of Southern California, where she holds a Viterbi Early Career Chair in Engineering. She is also a co-director of the Center for Artificial Intelligence and Society at USC and a co-director of the ORAI Interdisciplinary PhD Certificate Program in Artificial Intelligence and Operations Research. Her research is focused on responsible AI and is motivated by complex societal problems such as homelessness, substance use, and suicide. Today, Dr. Vayanos will discuss how AI research can help mitigate, stand by, there we go. Will help mitigate, you almost didn't know what she was going to talk about. Will help mitigate homelessness with focus on issues of bias and equity. Thank you, Dr. Vayanos.
Thank you so much. Thank you so much for the invitation and for the introduction. I'm really excited to be here. It's my first time at this conference, same as our first speaker. Eric has done a lot of the heavy lifting for me, introducing and motivating our problem. So today what I'd like to do is kind of talk about the AI side of things, and also trying to move a little bit beyond prioritization and trying to share with you how AI can actually not only help make these predictions of who is the most vulnerable, but also perhaps help support decision-making and make recommendations for who should be getting what resources. So in LA, just like in Seattle, we have a massive homelessness crisis. The local housing authority has at its disposal over 28,000 housing resources available to help. Most of these are already occupied. And meanwhile, every night, we have over 75,000 people sleeping on the streets or in shelters. And like Eric mentioned, we have severe issues of equity. In particular, Black people are severely overrepresented in the homeless population in LA. When you're in need of a housing resource in LA, you fill in this survey that Eric talked about extensively. This VI-SPDAT survey is this vulnerability tool basically asks you about any adverse experiences you have had. And the more adverse experiences you've had, the higher you score, and then you're prioritized for more supportive housing resources. In many communities, this is used like in a bucketed fashion, where basically the people scoring the highest are prioritized for more long-term permanent supportive housing interventions. Those who score in the middle receive rapid rehousing, the shorter-term voucher-based interventions, and those who score the lowest receive no resource, just supportive services. Bird's eye view of how this works. Obviously, this is there's a lot more nuance and detail that goes into making decisions than my pictures suggest, but still, let me share a little bit with you the high level. So when an individual is in need of resources, they fill in this survey, and their information together with this VI-SPDAT information gets entered into the HMIS, the Homeless Management Information System, which is basically a database that tracks all the interactions that individuals had with the system. When a housing resource arrives, people are prioritized for it using this vulnerability tool. And then in case conferencing meetings, it's basically decided who should be receiving this resource. So a lot more information goes in at that point than this simple score, but the score is used as an input to make that decision. So as Eric mentioned, right, perhaps we can use AI to help improve how we're doing prioritization. And what I'd like to discuss here is whether actually doing prioritizing and making this prediction in a way that is fair, whether it can help you make good decisions, good resource allocation decisions. So what we did, right, is we took the historical observational HMIS data. This is an observational data set, so we have quite a bit of selection bias. because resources historically had not been assigned randomly. We can work with community members, which is what we did in LA, right, to define a specific adverse outcome that we would like this tool to predict, and then use something called causal machine learning to help learn perhaps what is a better vulnerability score, meaning that it's going to more accurately predict and perhaps more fairly predict who is most at risk of these adverse outcomes. And indeed, you can do that, right? So in my figure, in the figure on the right, in the table on the right, I'm showing the area under the curve, so of the VISP dat. What this means, basically, this number means the higher it is, the better it is. It's a measure of how well we can rank individuals. 50% means we're basically making a random prediction. 100% means you're ranking everybody correctly when you're evaluating their risk. And anything in between 50 and 100, the higher you get, right, the better. So this historical VISP dat survey had very poor AUC, close to 54%, essentially close to random. With machine learning, this ML-driven score, we can get it as high as 72%, which, you know, having worked on many real-world data sets, this is actually quite good. And the figure on the left just represents this idea that we can correctly rank individuals, and basically the higher to the top and left you are, the better your model in some sense. We can also look at other metrics of accuracy, this calibration. This basically says how good are we at actually predicting the chance that someone has of seeing an adverse outcome. So on the x-axis here, we would, this is our prediction. We say that a particular individual, for example, has a 60% chance of having an adverse outcome. Among those for whom we say that, what proportion actually had an adverse outcome? If we're close to 60%, that would be, again, a good prediction. So this ML-driven model is very well calibrated. We're close to this diagonal line. Wonderful. Actually, our model is also quite fair. So if you look here, we're just doing the same exercise of plotting this calibration by race. We want for all races, this calibration plot to be close to the diagonal, basically thinking that this will be used downstream for making recommendations on housing. If I'm underestimating for a particular group their probability of experiencing an adverse outcome, I will give them fewer resources, right? So it's very important to make sure that across all races, we make predictions in a fair way. So now let's start thinking about resource allocation. So this score is accurate and it is fair in the terms of predictions. What if we use now this scoring rule that's really good to allocate resources? So in order to answer these questions, we build an AI model, a kind of simulator, if you will, which takes historical observational data, this HMIS data. It splits it into a training set and a testing set, like what we do in machine learning. We're going to train on the test set and on the training set and evaluate on the test set. We feed in a counterfactual policy. What this policy is going to do in this case is it's going to use this bucket approach. We take the vulnerability risk score, we prioritize people who rank highest for PSH, those in the middle for rapid rehousing, those lowest for just services. And then we simulate. What happens if we were to implement this approach in the real world? In order to do this simulation, we build machine learning models that are going to help us reason about what would happen to individuals if they were to receive a different resource than they got historically, right? We need this because otherwise it would take years and years to deploy this approach to see how would it work. And then we observe various metrics. So let's take a look. So these plots, they show the proportion of the population receiving permanent supportive housing in the top, rapid rehousing at the bottom. The different colors are the different races. The left charts show the VISP dat if we were to just use the historical scoring rule, and the right charts show this ML-driven risk score. What we see is that, first of all, white people get more resources than minority groups if we implemented this as such using the VISP dat. And using the ML-driven prediction, we see that things are a little bit more fair, but still white people receive more resources, which could be seen as controversial given my very first slide, and Eric, all that Eric said in his talk. What about when we look at exits from homelessness? So when we use the ML-driven tool, we have more people exit homelessness, right? There is a slight increase, so we're making kind of better use of these resources. And we are having perhaps what may seem as desirable, at least per our conversations with policymakers and the community, that minority groups tend perhaps to get more resources than white people, which again, given the historical inequalities and the current state of homelessness, may be seen as desirable. But still, is this the best we can do, is a question, right? Could we have a system that perhaps is more efficient, that makes better use of these scarce resources, and that also allocates them perhaps more fairly? So the question is, can we actually use AI to explicitly is going to give us policies that optimize desirable outcomes and that aligns with specific fairness goals that the community or that policymakers are going to help us define? The way to think about this question is really, well, people are more than just their score, right? And this is the point of case conferencing to some extent, right? So can we here try to make recommendations that go beyond just the score, and that policymakers and caseworkers can use in case conferencing to make better decisions, to optimize long-term outcomes for their system, and also to kind of lift some of the stress that goes into these extremely important decisions and alleviate some of the burnout that goes with it. So here's what we propose. We propose this AI system. As inputs, it's going to accept the type of fairness decide, which is going to be defined by the community, by policymakers, by working with them. So an example would be that we'd like to have fairness in allocation by race, something that, using the ML-driven policy wouldn't give us. And then an outcome to optimize. For example, we want to maximize exits from homelessness or minimize deaths. Our AI system is then going to leverage this historical HMIS data to build predictions, to reason about what would happen to individuals if they receive different resources than they did historically. And then we're going to actually design the policy. So that's where the optimization part comes in. We're going to actually, rather than doing just prediction, actually do optimization and select among all possible policies, what's the one that's going to best achieve what we want. And the output will be this optimal policy that is provably the best. So how this would work in practice, to make a recommendation, we would have people arrive in the system. Each time a new person arrives, we could say, this is the kind of resource they should be receiving, and we're going to put them in a queue for that resource. Each time a resource arrives, it's going to be given to the first person to have arrived in that queue in some sense, and then that person will leave the system, and so on. I'm not proposing, obviously, that this should be implemented as simply as such, but it could be used as a recommendation tool for policymakers. It has the advantage that when someone comes in the system, they already know what resource to expect, and we can even give them an estimate of how long they will wait to get that resource, which alleviates a lot of the uncertainty of waiting in this system, not knowing what you will get anything, and even less like when. In addition, this policy treats similarly situated people similarly, which we think is nice in terms of fairness and interpretability or transparency of the system. So let's look at some results. So here are my allocation fairness plots. So same as I had shown you before for the VI-SPDAT. So we see the VI-SPDAT was quite unfair in many ways. It was giving quite a few more resources, for example, to white people than to Black individuals. What we see that the policy I have highlighted, the optimal policy that is fair in terms of allocation, it gives resources at equal rates, more or less, to all individuals. And here we have asked the AI to prioritize minority groups, meaning to give resources at greater rates to those minority groups. We can fine tune again based on community input. On this line, I'm showing the proportion of individuals exiting homelessness. And what we can see again is that a policy that is like highlighted at the far right, which is the optimal policy that is fair in outcomes, it's able to result in outcomes for minority groups that are greater than for white people, which is again something we explicitly asked the AI to do. Our policies also result in far greater rates of exits from homelessness. So these are highlighted in green. So the third, fourth, and fifth rows would be policies designed through AI. We're not increasing the amount of resources here, but it increased the rates of exits from homelessness by over 5%, no matter if we just want a policy that optimizes outcomes or if we want policies that are fair, meaning that actually we can be fair at no price to efficiency. We don't lose any exits from homelessness essentially by trying to impose fairness. A natural question that you may ask at this point is, well, okay, you're optimizing these outcomes, but then doesn't that give resources to people that just benefit from them more rather than prioritizing vulnerable individuals? So what this plot shows is that actually, so on the x-axis, we have our predicted risk of an adverse outcome if we don't give you any housing. This is your vulnerability score. And on the y-axis is the proportion of the population that's going to receive each resource type. And what we see is that basically the vast majority of resources go to more vulnerable individuals. On the other hand, there are people that are scoring very vulnerable that are not getting resources. This would be essentially because we don't think they will, or the AI thinks they won't benefit from them. This would actually be a good way to identify people that are extreme risk and cannot be supported by giving them resources, which is also an important insight. A natural question is what happens to wait times. So historically, people wait on the street very long, as I mentioned, and also they don't know if and when they will get a resource. Average wait times for permanent supportive housing are close to a year. Average wait times for rapid rehousing historically are 213. AI-driven policies slash this by an order of magnitude. Average wait times are around 30 days for PSH and 18 days for rapid rehousing, which is also very important given the risk of adverse outcomes when people stay on the streets. Something else that AI can do is that it can help us reason about what would happen if we could actually increase the amount of resources in the system. This is very important for policy making and to perhaps help drive more resources to this system. This is what this plot shows. So original budget here would be the original amount of resources. We multiply it by a factor of 2, factor of 4, 6, and so on. What we can see is that, of course, with more resources, more people exit homelessness. But also there is a point where perhaps the benefit is less, there's less benefit just because no matter how many resources you have, perhaps some people need something different or something more or something else. Key takeaways. So first of all, there's so much more to each person than just a score. I genuinely believe we shouldn't be using these scores to allocate resources, which unfortunately many communities are still doing. AI can play a role in helping us use this additional information, this information that caseworkers know, this information that policymakers know, and that's important to help make these decisions. And basically it can help us design policies or matchings that are more efficient, that make better use of these very scarce resources, but are also more fair and more transparent. It can help us not only understand the performance of policies, but also optimize and identify policies that are going to align with what our community wants, with what our stakeholders want. And again, I'm not proposing that it should be just implemented as is, but it can be a very important decision support tool to help alleviate some of the burnout and some of the stress that that caseworkers and policymakers are facing. Thank you.
Yeah, you can. Thank you very much to all of our speakers. We actually have a few minutes before the end of our session is over. So if anybody from the audience would like to stand up and just ask questions of the panel while we're here before we take our break and move into the round table, more discussion oriented session. So I'll go ahead and wait. I see some folks are coming up, or maybe they're just exiting. Thank you. Yes, go ahead.
Good day, everyone. Thank you very much, Eric, and thank you, Phoebe, for sharing your research with us. My name is Ojobo Agbo. I am a recent graduate student of data science from Rutgers University, Camden, New Jersey. I find this very interesting because part of the work that I'm doing has to do with providing a solution for the Camden County over there in New Jersey. So the question I want to ask is, as it relates to working with the community, what has been like the two pressing issues that you guys have faced in carrying out this work, both from the technical point of view and from the community engaged point of view? Thank you.
Oh, okay. I'm happy to be the first to answer this, but although I think both of my colleagues here have probably important things to say as well too. I think that from building trust is the most important and difficult thing. I mean, oftentimes the people in our communities who are most impacted by the behavioral health and social problems that we are trying to work on as prevention scientists and as data scientists, these are folks who have the least access to education and the resources that would make them most informed and comfortable with AI. And I think that AI right now, maybe we've moved past the AI as killer robots fears, but we've now, I think, moved into a new set of fears, which is that AI is going to take away all of our jobs, that AI is going to, especially with generative AI, is going to, and large language models is going to do the tasks that even, the white collar economy that has emerged in, into the 21st century, that is part of the United States, that's really the core, engine of economic power in the United States, is going to be taken away by this. So what you really need to do is you need to do old-fashioned community-based participatory research, right? You just need to lean into talking to communities, listening to communities, providing forums for them to express what their fears are, but also what their wishes and hopes and dreams are, because I think that they have both genuine and understandable fears about technology, but also they have really exciting hopes for what technology could bring. And it's our job to facilitate those conversations.
Thank you.
Okay.
Yeah, thank you for the very nice questions. I completely agree with everything Eric has said. I can add something related to the AI research part. So in a lot, so this is one example of the projects I've been working on, but in essentially all of them, the main challenge is to understand the data.
Yeah.
I think there's this thing in CS that you take a data set and you apply your methods. and that's not possible when you work with real people, with real data. First of all, administrative data is really, really difficult to work with and to understand. It is messy. There's so much missingness. It's potentially biased, and you don't know in what ways. So, we've started working in this project back in in this bigger project in 2016, I think it was.
Like a decade.
Right. And it's been slow because it's so hard to understand the data. We met so many times with people who are entering the data. Whenever you start doing something that you think makes sense, like, wait, why are people receive resources before we see them getting scored? And it's like, well, there's delays. And, so there's so many complications that the only way to be comfortable that you're using it the right way, if it makes sense, or in the best possible ways, to really talk to people. And that takes time. You need to find the right people who would know, then make the right adjustments. So it's really, really challenging. And then having understood the data, AI research is, for this last decade that we've been working with it, initially there was very little about bias in AI and about how to mitigate bias in AI and how to make fair decisions. And so it's also been slow because we had to do the research. And while it's fascinating to do it and it's incredibly rewarding, like Eric is saying, it's also really challenging. So that's from the research perspective, what the challenges have been.
Thank you.
Can I add as well?
Definitely.
I do agree that when you're working with machine learning, the data set is as or a bit more important than the architecture of the algorithm itself. So one thing that could be helpful as well is to have this idea of the human in the loop within the decision-making process. Because yes, AI or the different methods that you can use to predict, classify, or generate, they are automatic, right? So you have input, then you process, then you have an output. But I think what is relevant is to have this human in the loop approach within the machine learning process where you have the teaching, which is about the data set itself, the learning, the algorithm, and then the inference and the validation methods that you use in order to see how relevant the output is to the community you're going to be making the decisions for. So what I will say is very quickly, because I know we don't have much time, is to have this human in the loop approach for any machine learning process, and thinking about that bias doesn't necessarily need to be a negative, has a negative connotation, because we saw the examples that the moment bias is identified, you can create a positive bias by prioritizing, creating a hierarchy to be able to kind of combat what is already there in a meaningful, responsible manner.
Can I ask a follow-up question? Okay, thank you. Still, so I want to ask, how do you see agentic AI supporting works like this?
So can I? So agentic is like, let's say it's the implementation of a large language model in order to create kind of a chatbot that can reason regarding on any topic that you have pre-trained it. So right now, all of these large language models, they can be considered generic or to kind of have a common knowledge. But then in order to create an agent for a particular question, you will need to bias that to the, I'm just doing this so to be able to answer, let's say, housing questions. So the effect that this will have right now is regarding how you introduce this agent to the community. Because one of the main issues or one of the main concerns that people have is that you don't want to be not knowledgeable, that you're talking to someone that is not human. I think these will expedite a lot of the process that we saw already on the prediction or the ranking or the decision that has to be made based on some quantifiable methods. But I think it's more about how do you introduce these in which of the process for the decision making. So it will change, yes, tremendously the whole process. But I think the way that it's introduced should be efficient enough so people know what they're interacting with.
Thank you very much. Thank you.
I think at this point, sorry, we have one more. Please go ahead.
Sorry.
Yeah.
Good morning. My name is Aaron Lenahan. I'm a social scientist at the University of New Mexico. Thank you for the talks. They're very interesting. I had a question about this, the LA homelessness, about the idea of fairness and how that's kind of being defined. It seems like in a program where you're allocating scarce resources, you use kind of a distributive justice framework, and there's a few kind of ways to conceptualize fairness. If you're doing it based on need, which is what's implied by the vulnerability framework, that suggests you'd be optimizing for certain outcomes. But then when you talk about equity, I assume you're optimizing on some other set of outcomes. And I'm curious how you're, do those come into conflict? Those two kind of trying to optimize on two things? And when they do, how do you deal with that trade-off?
I think this is something that we wrestled with for years. This is actually, you're getting to kind of the heart of some of the intellectual challenges here, right? When you're working with community, they will often say, we want this thing to be many, many things simultaneously, right? We want it to be as efficient so that we get as many people housed as possible, but we also want it to be fair. And they may be, and the community themselves may not know what fair really means. Fair with respect to what, right? So do we mean fair with respect to the allocation of resources, or do we mean fair with respect to the outcomes that one might get from those resources, let alone some of the more esoteric issues of, do we mean actually parity, or do we mean statistical parity? You know, are we talking about sort of a John Rawls conception of justice or not? I mean, it gets deep very fast. And ultimately, part of what my perspective on this is that we as the researchers should not be making those decisions. We should be presenting these complexities to the community and asking them how they want to fall down on it. And in fact, and I'll let Phebe talk about this in a minute too, but one of the issues that we ran into was that even though we in this early days of this project could start to talk about some of the resource allocation fairness issues that Phebe was showing you and how much that was mitigating additional fairness issues, there was a discomfort in having a AI agent making decisions about who gets what resources. So while there was a sense that using predictive analytics to improve the prioritization process was something that the community was comfortable with, because they could wrap their heads around that. The idea of having even a decision aid that said this person should get this housing resource and this person should get another housing resource was something that they were not comfortable with us doing. So equity issues get further complicated by what is the community comfortable with and how do they understand the problem.
So I agree again with everything that Eric said. So a few additional points. So the reason we looked at these metrics of like fairness in allocation, fairness in outcomes is, and why we focused on race is because from all the conversations we've been having in the last 10 years, this is, you know, first of all, race was like one of the main things on people's minds. And the second one is that this is how they themselves were looking, is our system fair? So if that's how you're evaluating your system, it seems natural, perhaps, to design it in a way that it would do those things. Again, it's not to say that this is better than prioritizing by vulnerability. I certainly understand the value of prioritizing by vulnerability, and I see that as being fair in many ways. It just, again, like Eric said, it's a trade-off. And it's up to the community, to policymakers, to stakeholders to decide how they want to balance these very conflicting objectives. We can provide like tools to help support that decision or help them make that decision, because I don't think that a human being can predict, if I make decisions in such and such ways, this is the outcomes that I will see. We would need to try it in the real world. And so what we're providing are these tools that can perhaps help make these extremely hard decisions.
I would just add one little thing here. I mean, I'm really excited and happy that I was sitting here while you were presenting. I think this is a really careful thought process to get to where you are right now. And in order to add to this question of fairness, there is, I mean, go back to the idea of machine learning process, right? So you have the data, the algorithm, and the output. There are already methodologies developed in order to quantitatively find the fairness metrics on your data set, right? So you can select protected attributes that you would like to test through to see the outcome, right? There are ways that you can evaluate your algorithm to see how fair it's predicting, and then the outcome regarding to the consequences from historical data that you have. So there is a method that I use that is called 360 FAIR. I mean, I can share it later, but this is how they do it. So they develop different specific methodologies for the data, the algorithm, and the output. And what I think it's really, really interesting in the case study that you're presenting is that you have historical data of the consequences. So I think that's how fair, like that's your last point about no human being can say, if I do this, then that's my outcome in the next 5 years, but you have the data to see the decision made and what was the consequences. How can you back engineer to be able to change those consequences? And then that thinking in the machine learning process, if it's helpful for that.
Thank you.
Everyone. Can we put back up the QR code for our final plenary? I just want to leave you all today with that in case you didn't catch it at the beginning. And can you all please join me in another round of applause for our speakers? And thank you all so much. We're going to take a little break, and when we come back, we'll have an opportunity to have more one-on-one conversations and a roundtable session here in this room. All right, take care.